In this video, we are going to understand the concept of sampling theorem. There are basically two statements of sampling theorem. First, we will discuss these statements and then we will understand what these statements are actually stating. First statement is a continuous signal of frequency FM Hertz can be represented in the form of samples with frequency Fs Hertz, where Fs should be greater than or equal to 2 FM. That means if you are having any analog signal, you can convert those analog signal into its corresponding samples, or you can say provided the sampling frequency, that means the frequency of the samples should always be greater than twice or equal to the modulating frequency, that is FM, that is Fs should always be greater than or equal to twice of FM, where FM is the frequency of the modulating signal. You can understand the concept with the help of this diagram. As you can see, this is the sinusoidal signal. These are the samples, fixed height or fixed amplitude samples of frequency Fs Hertz. When you combine these two, you will get samples of various amplitude according to the amplitude of modulating signal, provided the frequency of these samples are Fs Hertz. So this is what the first statement is saying. Then a continuous time band limited signal can be perfectly reconstructed from its discrete samples if sampling frequency is Fs. So that means now if you have these samples, with the help of these samples you can reconstruct your modulating signal or the analog signal. This is what the second statement is saying. That means you can convert your analog signal into its corresponding samples, as well as if you have these samples you can reconstruct your analog signal. So these are the two statements which say about the sampling theorem. Now this is the time domain representation of any signal. This is the frequency domain representation of the signal. This is the FM Hertz modulating signal. Then these are the samples. You can see these samples. Now I have drawn three diagrams. This first diagram is basically the condition of Fs is equal to 2 FM. The second is Fs is greater than 2 FM, and third is Fs is less than 2 FM. Because the question always arises why Fs should be greater than or equal to 2 FM. So if it is less than 2 FM, you can see the diagram, these values are overlapping. So because of these overlapping, when you reconstruct your signal, you will not be able to reconstruct your signal properly. That is why we keep the sampling frequency either greater or equal to. This is the condition of equal to, where using a proper filter you can reconstruct the signal or you can get your modulating signal. This is the least condition. After that, something like this will happen. And this is the proper condition, greater condition. You have sufficient guard band, which is help us to get the or recover the signal properly. So this is what the concept of sampling theorem. Now there are basically two types of sampling. One is natural sampling, second is flat top sampling. So now we will see how natural sampling and flat top sampling constructed and how it works. So there are two types of sampling. One is known as natural, another is known as flat top. There is one more type of sampling which is known as instantaneous sampling, but in instantaneous sampling the width of the pulse is almost zero, which is not a practical situation. So that is not used practically, that is just on a theoretical concept basis. So practically we have two methods, which is natural and flat top. In natural sampling, as you can see, this is the modulating signal. These are the various samples. In natural sampling, the top of the pulse gets the shape of the modulating signal, whereas in flat top sampling you can see the top of the pulse is flat. So originally the top of the flat is flat. So this is somewhat easier to generate, whereas you have to keep the shape of this waveform as it is, or you can say as per the modulating signal, this construction is somewhat difficult. So there are two methods how they works. Let us see first. In this natural, you are having a signal ft, that is your modulating signal, and a continuous train pulses of fs frequency, that is sampling frequency, is multiplied with this. So gt is basically multiplication of ct and ft. So you are getting the pulses with how much frequency? With fs frequency, because ct pulse is having frequency fs. This switch is closing at the frequency of fs hertz. So when this switch is closed, gt is nothing but ft into ct, and when this switch is open, gt is nothing but 0. So that means either you will get this or 0, or this or 0, or this or 0. So this way you are getting this circuit. Whereas as far as flat top sampling is concerned, we are using two switches. One is known as sampling switch, another is known as discharge switch. So first we trigger this sampling switch, this signal keeps, and this is open. So this capacitor is charged with the maximum value of ft. Now we keep this sampling switch closed and we trigger this, and this is on. So now capacitor will discharge. Capacitor will discharge, and then the next instance again we will close this and open this. So this way what we are actually getting is, this is the modulating signal. So till this value your signal is charged, capacitor. Now it will remain till this position and then it will be discharged. Then again sampling switch will force to capacitor to get charged till the value of the modulating signal. That means this instance the capacitor will be charged to this value, and then it will remain till this value, till the width of the pulse, and then it will get discharged. So with the help of sampling switch and discharge switch, you are charging the capacitor to the maximum value of the modulating signal which we are getting, and then holding this value for the sample duration, and then discharging it through the path. Okay, so this is how flat top sampling is working. So basically the principle of natural sampling is chopping principle, because you are chopping the signal, either you are getting the signal or not getting the signal. In this flat top you are following the principle of sample and hold, because every sample is holding its voltage till the next sample arrives. So this is how you are getting this process. Now there are some drawbacks of natural sampling. First is it needs complex circuitry to maintain the shape of the pulse. Second, pulse shape needs to be maintained. Because of this only you need a complex circuitry. Whereas you have some advantages of flat top sampling, which is pulse shape need not to be maintained. As you can see, the pulse top is flat. No need to maintain the shape of the pulse. So because of this, it avoids the need of complex circuit. So the drawbacks basically of the natural sampling are the advantages of flat top. So these are the two types of sampling. So in this video we have understood the concept of sampling, how signal can be converted into its corresponding samples, and how from the corresponding samples you can get your signal back. And then we have understood the concept of two types of sampling, which is natural and flat top. I hope the concept of sampling is understood to you. If you have any doubt, please write it in the comment section.